So last week on Wednesday, Thursday, Friday, you had some assignments to complete while I was out. And I wanted to go over and review constant of proportionality and what that number means whenever you find it, as well as how to write an equation for a proportional relationship, which is everything you did those 3 days. So let me go ahead and share my screen, if it lets me. All right, so we're going to start with just finding the constant of proportionality. So you learned last week that the constant of proportionality is the same thing as unit rate, and that we find it by taking the y value divided by the x value, and that'll give us r. And r is just the letter we use to represent constant of proportionality or unit rate. So both of these are r. So with a graph, because you learned graphs and tables last week, with a graph, you want to find that perfect point. And what I mean by perfect point is when you have your x and y lines, you're looking for a point that sits right where those two lines cross. So this is a perfect point because it is at the intersection of an x and y line. So I'm going to look at my graph. We have free throws attempted and free throws made. And I'm going to go along my x, and I can see there's a perfect point at x equals 15, and it's also a perfect point of y equals 12. So I'm going to use the point 15, 12. And remember, when we write an ordered pair, it is always x, y. So using my equation, r equals y over x, or y divided by x, I'm going to substitute 15 and 12 in for the letters x and y. So r equals 12 is my y, 15 is my x, and from here you can either simplify the fraction or you can divide it out and get a decimal. Either answer would be correct unless it asks for a fraction or a decimal. So I'm going to do simplifying. And I know that 3 divides evenly into both 12 and 15. So I'm going to divide the top and the bottom by 3. 12 divided by 3 is 4. And 15 divided by 3 is 5. And if you wanted to write that as a decimal, it would be 0.8. Any questions how I found the constant of proportionality, my r? No questions about that? All right. So the other part of my question wants to know what this means. What does it mean if my constant of proportionality is 4/5? So if we talk about in terms of free throws attempted, we could say for every, and I'm going to abbreviate free throw she takes or attempts, she makes 4/5 of them. So for every free throw she shoots or attempts, she's going to make 4/5 of them. So if she does 2 free throws, we would take 4/5 times 2 to figure out how many she would make, which would be 8/5. So just over 1. Does that make sense? Any questions about that? I don't see any questions popping up. So I'm going to assume everybody is okay to move on to the table. All right. When we have a table, because I can look at my graph and I can see it's a straight line, it goes through the origin. It's easy to see if it's a proportional relationship or not. With a table, we have to figure that out. So number of windows and the amount of window cleaner. Number of windows is going to be my X. Amount of window cleaner in ounces is my Y. And the first thing I want you to notice is the very first pair of values is 0, 0. If I were to graph this, 0, 0 is what point on the graph? What do we call it? It has a special name. Drop it in the chat. The origin, Karen says. And that is correct. So 0, 0 being on my table tells me that this relationship passes through the origin. And that is one of the two things that we look for when we're trying to decide if a relationship is proportional. The other thing is it's a straight line. And we can find that by figuring out the constant of proportionality as we go through. So we're going to do y divided by x for each line. So we're going to do 16 divided by 2, and 16 divided by 2 equals 8. I'm going to do this all the way down my table. So 24 divided by 3 is 8. 32 divided by 4 is 8. 40 divided by 5 is 8. And 48 divided by 6 is 8. So what do you notice about all those numbers all the way down my table? What do you notice about them? Okay, they're all the same. They all equal 8. Okay. So if we know it passes through the origin and our rate is equal to 8 all the way down the table, is this a proportional relationship or not? Elizabeth says yes. Alayla says yes. Okay. Maite says yes. And I hope I said your name correctly. Yes, yes, yes. All right. So yes, it is proportional. What is our constant of proportionality then? So R is equal to what? 8. Okay. So whenever I go down the table, whatever number I find for each pair of numbers in the table is my constant of proportionality. And what does this mean? It means every window needs 8 ounces, and I'm putting ounces because that's what it's being measured in, of cleaner. So whenever I clean those windows, it's going to take 8 ounces of cleaner for each and every single window I clean. So if I clean 10 windows, how many ounces of cleaner would I use? How many ounces of cleaner would it take for 10 windows if one window is 8 ounces? Brandon says 80. And that is correct, because all we have to do is take our ounces of cleaner times the number of windows to figure out how much altogether. Which leads me to the next thing that you did. So you also learned how to take this number, this R that you find, and write it into an equation. And for proportional relationships, we use the equation y equals rx. So R is our constant, and I'm abbreviating, of proportionality. Y represents any y value, and x is any x value. So once I know my constant of proportionality, my R, I can take this number and substitute it for R in my equation and just leave y and x alone. So if I wanted to write the equation for this table, the number of windows and the amount of cleaner, I would write y equals, instead of writing R, I'm going to write 8 because that is the number that I found is our rate, x. So the equation for this table is y equals 8x. Does that make sense? Are there any questions about how I did that? Yes, it makes sense. Okay. All right, are we good to move on to the next one? All right, let's go ahead and move to the next slide. And this should look familiar because it is an assignment that you had last Friday. And I had a lot of questions about this one, so I wanted to review it with you. The graph shown displays the relationship between time in minutes and distance in kilometers that Ella runs. And our first question, you guys didn't have this on yours, but we're going to go ahead and do this. It says define the variables and write the equation. So if you see the words define variables, all that means is to say what x is equal to and what y is equal to. So x on my graph is time, and that's measured in minutes, and y is my distance, and it's measured in kilometers. And now we need to write the equation. So y equals rx, and we need to find what r is equal to. So how am I going to find what R is equal to? How do we find what R is equal to? What do we do? Nobody? Okay, so remember, R, we do y divided by x. Since I don't have a table, I have to find that perfect point on my graph. And I can see there is a perfect point at 24, 4. So I'm going to do 4, which is my y, and 24, which is my x. So 4 divided by 24 equals r. And again, you can divide it out and get a decimal, or you can just simplify the fraction. So I know 4 goes evenly into 24, divides evenly into it. So I'm going to divide by 4 on the top and the bottom. And 4 divided by 4 is 1, and 24 divided by 4 is 6. So my R, when I rewrite this, is y equals 1, 6, x. Okay. Any questions about how I got that number? None? Okay. So now that I have my equation, I can use it to figure out other numbers. So we already know a few things. I'm going to go ahead and make a table. So we have time, which is in minutes, and we have distance, which is in kilometers. And we know that in 1 minute, she can run 1/6 of a kilometer, because that's what my unit rate tells me. And our graph wants to know, and we also know that she can run 4 kilometers in 24 minutes. And I got those numbers from this right here, from my 24/4. Okay. The first question wants to know, in 15 minutes, how far can she run? So how am I going to figure that out? Am I going to multiply or divide? Okay, I see an answer for multiply. Okay, so to go from 1 to 15, we do multiply. So we're going to do the same thing here. And if I take 1/6 times 15 over 1, I'm going to get 15/6. Okay. Alayla, why do you think it's divide? Okay. So if I cover up 24 and 4, pretend it's not there. To go from 1 to 15, I know that 1 times 15 will give me 15. So if I multiply by 15 on the left side of my table, I have to multiply by 15 on the other side. That's how I know what math operation I need to do. So I look at my unit rate and figure out how do I move, or how do I go from this number to this number. We wouldn't divide by 15 to get 15, we would multiply. Does that make sense? Okay. So that's one way to solve it. And just to show you that I did the correct thing, I can use my equation to solve this. We have y equals 1/6 x. And we know that 15 minutes, we are talking about x, because my graph tells me that x is my time in minutes. So I can take this 15 and substitute it in for x in the equation and rewrite it as y equals 1/6 times 15, which is exactly what I did down here on my table. I did 1/6 times 15. So y equals 1 times 15 is 15, 6 times 1 is 6, so 15/6. It's the same number. So once you know the equation, you can actually substitute numbers in for x or y to solve for the other variable. Any questions about that? All right, let's look at the second one. How long does it take Ella to run 7.5 kilometers? So now we know she went 7.5 kilometers and want to know how long that is going to take her. So is kilometers my x value or my y value? It is my y. So I'm going to take 7.5 and substitute it for y in the equation and rewrite it. 7.5 equals 1/6 x. So I'm going to drop down to the bottom here and rewrite this. So with this, to solve it, we want to get x by itself. 1/6 x is the same thing as taking 1/6 times x. So to get x by itself, we have to do the opposite operation. So what is the opposite operation of multiplication? Division. So to get this by itself, I'm going to divide by 1/6. And since this is a proportional relationship, what I do on one side of the equal sign, I have to do the same operation on the other side of the equal sign, just to keep things balanced. So 1/6 divided by 1/6 is going to give me just 1. And 7.5 divided by 1/6, I'm going to rewrite. So 7, I'm going to write it as a fraction, divided by 1/6. We're going to change 7.5 to an improper fraction. So 2 times 7 is 14. plus 1 is 15. Denominator stays 2, divided by 1/6. And now we're going to do our keep, change, flip. I'm going to change colors. So 15 halves stays the same. Division becomes multiplication. And 1/6, we're going to flip our denominator and our numerator. So 6 is now our numerator, and 1 is our denominator. And I can multiply. So 2 times 1 on the bottom is 2. 6 times 5 is 30. Sorry. Carry my 3. 6 times 1 plus 3 gives me 90. And I can simplify this. So 90, I know half of 90 is 45. So 45 minutes equals my x. So if I come back up here, I know that x equals 45 minutes. So to run 7.5 kilometers, it is going to take her 45 minutes. Any questions about that one? We have one more before I tell you about what you're doing today. So the last question wants to know how far in 1 hour. On our graph, how are we measuring time? Are we measuring in minutes, in seconds, in hours? How are we measuring time in this problem? Minutes. The question is asking about what measure of time. So how far can Ella run in 1? What is our measure of time in the question? It's asking about hours. So before I can solve this question, what do I need to do first? All right. We need to change hour to minutes, and Karen already told us that there are 60 minutes in an hour. So we're really asking about in 60 minutes. And now I can solve. So I'm going to write my equation again. Y equals 1/6 x. Minutes is my x. So y equals 1/6 times 60. And if you take 1/6 times 60, what answer do you get? Okay, 66, and if we simplify that, it gives us what? 10. So in 1 hour or 60 minutes, she can run 10 kilometers. Any questions whatsoever about any of the problems we did? No? Okay. So let me stop sharing that. And let's talk about what you are going to do today. All right, so from the home screen for math, whenever you click on weekly lessons, it's going to bring you here. And you have, the first two are just review videos. It is a different teacher here at the school. I pulled her videos just in case you wanted another person or another teacher's explanation. So if you feel you need to watch them, they are there. And then you have one assignment today, and it is this constant and proportionality review. And there are 3 slides that you're going to do. The first one wants you to use the X and Y to figure out the constant of proportionality, and you just drag the pieces over where they go. You're only going to use 5 of them, so you will have some left over. The second slide, you're going to find or use the table up here to answer all 3 questions and just drag your answer into the box. And then the last one, you have to complete the table. So you're going to slide some of these over to the missing spots and then tell me what the constant of proportionality is. Once you are finished with that assignment, if you feel that you need to go back and look at last week's assignments, that would be a good place to start after you finish today's. I'll catch you up in just a second, Alexander. Any questions about your task for today? All right, if there are no questions, this meeting chat will be open until 12:35. So if you need to pop back in and ask questions, you can. If you think of something after the meeting is closed, you can come in during Red Hawk time this afternoon and ask your questions then. And as always, you do not have to stay signed into this if you do not want to. That is completely up to you. But I will be here for the next 20 minutes.